Hello everyone. Can you see my screen? Can you see my screen? Hello, am I audible? Hello, guys, can you see my screen?
Yes, yes.
Okay, fine. So let's begin. So welcome to the week 11 of the doubt and problem solving session of the course Techniques of Material Characterization. So I hope you guys have watched the lecture and will try to solve some problem which we'll try to solve some problems which will be helpful to solve your assignments. So let's start our questions and discussion. And if you have some doubts from the previous classes, then you can also ask that if you have any doubt or problem or any questions. If not, then uh, we can discuss this week's problems. Okay. So yeah. So the first question is about the intensity of the wave. So it is asking about the relationship between the intensity of any wave with the amplitude. So whether it is proportional to the square of its amplitude, inversely proportional to the square of its amplitude, or just proportional to amplitude and inversely proportional to its amplitude. So if you have seen the starting lecture, maybe it is covered in that. So can you give the answer for this question, and then we
A,
will discuss. Huh? Which one?
A,
A or what? C or A?
it's A.
A. Okay, fine. Okay, yeah. So anybody else? What could be the answer for this? No one. No one knows. Okay. So I think this is just the slide, but here the in the lectures you can see the explanations. So here you can see for the simplicity they have taken the geometrical geometrical construction, so maybe avoided by use of analytical treatment. So here they have included the complex number are used to represent the vectors, okay, for the simplicity. So here this is the your complex plane. Okay, so complex means what? Where the iota is used. What is the value of iota? Iota is equals to root over minus 1. Okay, so this complex plane where the real planes are also plotted. Okay, so here this is your imaginary numbers as coordinates. Here you can see iota to iota, here minus and 2 minus 2 iota, and this is your real. Okay, so this is your imaginary plane. So here any point in this plane or vector from drawn the origin. Okay, so from the origin if you will draw any vector to the point, it will represent as a complex number. Why? Because it is in the complex plane. So how it will represent? It will be like a plus b iota. Okay, and this length will be I mean given by the amplitude. So the amplitude and the phase of the wave is, so a will be your amplitude and phase will be your and the length of the vector, and the phi is the angle between the vector, this vector, and the axis of the real number. Okay, so this will be the real number and it is the angle between these two. So here it is saying the intensity of wave, right? So here it is intensity what I is proportional to the square of its amplitude. So here a is represented sorry, amplitude is represented by the a. So I, here you can see in this expression, I equals to a square. Okay, so here the quantity is obtained by multiplying the complex expression for the wave by its complex conjugate. So how? So here this is the expression for the where you can express this by e equals to a sine 2 pi nu t minus phi. Okay, so here for if you will include the this complex expression, then here a multiplied by e iota phi. So here if you will give this power series expansion, then when you will put the e to the power iota phi, then it will be cos phi plus I sin phi, right? So here what it is saying, multiply the complex expression. So here, so how, so this is the expression e to the power I phi. So what will be the its complex conjugate will be a e to the power minus I phi. So when you will multiply this, then here will be iota square square of iota. So what will be the iota value is root over minus 1. So if you will do the square of this expression particular, then it will come minus 1. So it will come around a. So it will come to a square. So the intensity of this wave is proportional to the square of its amplitude. Okay, not just amplitude, right? So this is for the simplicity they have taken the imaginary plane for the solving to make it easier. So in the question was the intensity of any wave, so it is proportional to the square of its amplitude. Okay, so the answer is a. Okay, so the next one is the structure factor. So it is asking about how it is defined, whether it is the wave scattered by a single atom of the unit cell or the resultant wave scattered by all atom of the unit cell. The resultant wave is scattered by any two atoms present in the unit cell. The resultant wave is scattered by the unit cell. So can you answer this question, or any if you have seen the lectures, just be aware, or of this take a notice of the structure factor and the atomic scattering factor. Okay, so there will be the two things. So keep in notice that before answering this, so that you won't get wrong. So what could be the answer for this?
B.
What?
B.
B. Okay, fine. Anybody else?
This is B.
D or B?
B, B.
B. Okay, fine. Okay, so let's see, let's discuss this. So okay, so the structure factor. Okay, so here the scattered wave from any atom in the or from the each atom in the unit cell require addition of the complex numbers representing the amplitude and the phase of each wave, as we have discussed in our first question. So the amplitude of each wave is given by the appropriate value of atomic scattering factor. Okay, so just I have said that keep in mind that there is difference between the structure factor and the atomic scattering factor. So the amplitude of each wave, okay, the wave coming out of the plane. So the wave coming out of the plane, so the amplitude of that each wave is given by the appropriate value of the atomic scattering factor. So this is represented by this F for the scattering atom considered, and the value of sine theta by lambda involve the reflection. Fine. So here if you have noticed, this is a bit basic crystal structure terminology, that where the phase of each wave is given in terms of the this HKL reflection considered. So this will be your plane, and the considered UVW, that will be, sorry, that will be your coordinate of the atoms. So the resultant wave is scattered by all the atoms of the unit cell is called the structure factor, while the amplitude of each wave is given by the appropriate value of the atomic scattering factor, because it describes how the atom arrangement given by UVW of each atom affects the scattered HKL beam. Okay, so if there is some wave is coming from any a plane like HKL, so and that will be given by your UVW. So the resultant wave is scattered, okay, by that atom of the unit cell, right, is called the structure factor. So in the question what they have asked, the resultant wave is scattered by all the atom of the unit cell. So B is the definition of the structure factor. Okay, and it is represented by this capital F and obtained by adding together all the waves scattered by the individual. So there are many waves are coming. So if you will adding all the waves scattered, then it is represented by this expression where the F is equal to summation of n equals to 1 to n a e I to the power, sorry, e to the power I phi. Okay, and when you will expand this, so it will given by this term where H U K V and LW. So where I have told you the terminology, what does it express, the HKL and the UVW. So this formula will be for your calculating the structure factor, and from here you can calculate for any of your crystal, whether it could be a simple cubic or the base centered or the body centered or the face centered and whatever. So this will be your main formula. So keep in mind this formula. Okay. So the structure factor is the resultant wave scattered by all atom of the unit cell. Okay, not just from the one atoms. It's from the all, because all the waves are coming from the each plane. Okay, so here also this structure factor this structure factor, a complex number expressed by the amplitude and the phase of the resultant wave. So this gives the, question will also come in the next question, how it expressed. So amplitude of the resultant wave in terms of the amplitude wave is scattered by a single atom. So the atomic scattering factor, which is F, the modulus of S is defined as the ratio of the amplitude. Okay, so this is structure factor is what, amplitude of the wave is scattered by all the atoms of the unit cell divided by amplitude of the wave is scattered by one electron. Okay, so here when you will consider the, or when you will see the formula for the atomic scattering factor, this is for what, amplitude of the wave is scattered by an atom. Okay, it here it is by all the atoms. Okay, so here that's why it is multiplied by the n, it is given by, so F equals to n into atomic scattering factor. Okay, so when you will solve this, you will get this. So this is the relation between that. So here this atomic sorry, the structure factor is what, the amplitude of wave is scattered by all atoms of a unit cell. Okay, while the atomic scattering factor from by an atom with a z electrons or from the unit cell. So the answer is resultant wave scattered by all the atom of the unit cell B. Okay, so the next one is structure factor is a complex number. Just I have shown you in the last slide only. Only amplitude of the resultant wave, phase also, both phase and amplitude, and neither amplitude or phase. So just tell me the answer. I just showed this. What? Just amplitude of the resultant wave, or the phase
C.
also, or both? Okay, fine. See. What about others? No, I just showed you and I told you also that this will come in the next question. Okay, so I will again show the same slide. So here the structure factor is general a complex number and it expresses both the amplitude and the phase of the resultant. I have shown you in the formula also. This formula, okay, so here you can see that it is consider of both, it depends on both the amplitude a and the phi, okay, so that's why it is something that express both the amplitude and the phase of the resultant wave. Here you can also see in this formula, this is the phase and the amplitude, okay, f is given by the summation of n equals to 1 to n a e to power I phi. Okay, then here you can expand this and you will get a structure factor. So this will represent by both amplitude and the phase of the resultant wave. When you will see that this concept where in the lecture uh, there is explanation regarding your how to solve this by including the imaginary plane, then you will be able to get it much more easier, and how you can how there you can include or they are expressing by including the amplitude and the phase of the resultant wave for the calculation of your structure factor. That is very important. So here answer is your b, sorry, the answer is your c, actually both amplitude and the phase of the resultant wave. So I got I mean did it from the last slide, so that's why I wrote the b, but let me correct this, it is c. Fine. So the next question is now here we will be moving towards your the crystal structure. So the if you know what is simple crystal structure, then here it is asking about whether the structure factor is depend on the HKL independent or the depend on the H plus K plus L or none of this. So if you know how to calculate the structure factor for the SCC simple crystal structure, then you can give the answer. So what will be the answer for this if you know the expression?
A.
What?
It's A.
A. Okay. What about others?
A.
Huh?
A
Just speak little loudly.
depends on HK and L.
Huh? I cannot hear you properly.
Depends on HK.
What? A, B, C, D,
A.
A. Okay, fine. Okay. So, huh. So here, if you will see, So structure factor for the simple crystal structure. So in simple, so here they are taken the simple cubic crystal structure. So here there are the atoms, 8 atoms, and they are located at the corner of your unit cell. Okay. So if you will calculate the number, so here 8 atoms, and the each this will share with the um, another 8 unit cell. So here 8 is multiplied by 1 by 8. So the total atom will come is 1. Okay. So here when you will UVW is what the for this simple cubic structure is your 000, or the you can take a 111 or like that. So here if you will calculate for 000, then in the formula of the structure factor is given by what, like I have shown you in the last slide how it is been calculated. So f is multiplied by h to power 2 pi iota hu plus k v plus lw. So when you will put the, because this is what the coordinate, so here if you will take by this atom, so here it will be like 000. So when you will put the 000, what it will come, e to power 0. So e is to power 0, it means what, 1. So structure factor is what is f, the atomic scattering factor. Okay. So here if what it will give, it will, I is what equals to only the square of f square, so it will come f square. So here it is not dependent on the hkl. Okay. If it is dependent on hkl, then here something should come. So it is not dependent on the hkl, it is independent of hkl. Okay. So the answer is b. Here also you can see in the simple cubic crystal structure, this is the XRD like we have seen in our previous lectures, that how we get the XRD and what are the information we get. So if you will do the XRD with X-ray diffraction, you will get this kind of a peaks. So this is XRD pattern of this compound, and which is a simple cubic perovskite unit cell. So here you are getting a 100, 110, 111, 200, 210, 211, like that all. So here it is not dependent, like f is equals to f square. So what it's mean, that it is not bounded by any sort of a combination of your HKL. So it is independent of your HKL. So we will see in the further that how others are given in terms of HKL, or what is the criteria for identifying a different crystal structure. So here it is independent of your HKL. Okay, now the question is about the base centered crystal structure, and this is just simply asking the location of having, I mean having 2 atoms per unit cell are located where. So if you know base center, I will, before showing the slide, I will just dictate you that the base center, it means what, you have atoms at the corner and at the base, I mean in the bottom base and at the top base. So if you know that how to locate, or how to go to that position, so you may probably able to answer this question. So just quick think and give me the answer. I just said, remember, the atoms, 2 atoms are there, so one set of atom is at the corner and another is at the top base and the bottom base. You can take any one.
C.
C. Okay, fine. What about others? Are you able to
It's
get
A.
it? Huh?
It's A.
A. Okay, fine. What about others? Just think. If you don't know that how to draw the planes and this how to get it done, I mean drawing planes and lines and the coordinate system, just refer to the Callister book. There you can find it very easily. They have explained it very well. Okay, so I will not give so much time to this, and I will just show you this. So here this is base centered. What I have showed you, this is base centered orthorhombic. So here I said that the atoms at the corner and the atoms at the base, top base or the bottom base. So this is what, this is 0 0 0. If you will take a suppose this as a coordinate, okay, so here this will come what, 0 0 0. And if you want to reach to the location of this atom, then how you will move, you will move half in the x direction, then half in the y direction, and you will reach. You don't need to go to the z direction. So for this the 0 0 0, and for this you have to move half to the x direction, half to the y direction, and 0 to the z direction, and you will reach to that atom. So the what you will be the coordinate, it means the UVW, there will be one which is 0 0 0, and the UVW, so it is half half 0. So this is what the base centering translation. So with respect to this you can translate to the other unit cell. So here if you will try to calculate the number of the atoms, then this 8 atoms will share with the 8 unit cells. So 8 is multiplied by 1 by 8, and this 2 will again share with the 2 unit cells, so the half, so it will come 2. So the number of atoms here, it is having 2 atoms per unit cell are located where it is 0 0 0 and the half half 0. So the answer is C. Okay, fine. Did you get it or not? It is very simple. Okay, next moving towards the BCC, which is body centered crystal structure, and it is asking about the forbidden reflection. Okay, so shows forbidden reflection when HK are mixed, unmixed, and H plus K plus L are even or odd. So what is the answer for this? Remember, this is BCC. What could be the answer? It is not asking about to being a BCC crystal structure. What should be the criteria? It is asking about the shows the forbidden reflection when.
It's D.
D.
Okay. What?
When
Somebody
HNK plus L is equal to odd.
odd, and somebody also said something.
D.
B. Okay.
D. D.
D.
Last.
Okay.
Last one.
Yeah. Yeah. Okay. But okay. Fine. Yeah. So this is the lecture where you will get, and this is also very easy. So in the lecture they have in the lecture it has been explained that how to calculate the structure factor for each and every kind of a crystal structure. So BCC also, so here for the atoms are located at the corner and one atom at the center. So that's why it is called the body centered. So the UVW for this atom is what, 0 0 0, and to reach to this equation you have to go half to the x direction, half to the y direction, and half to the z direction. Okay, so this is your location of these atoms. If you will calculate the structure factor here also, then what if you will put in this formula of structure factor, then here it is what, um, it will come half. To just place the value of your for this it will be 0 0 0 for the 0 0 0, and here it will be h by 2, k by 2, l by 2. So when you will solve, what it will come, 1 plus e to power pi iota and into h plus k plus l. Okay, 2 and 2 will get cancelled. So The for h plus k plus l is even. Okay, so for that, if your h plus k plus l is even, then the structure factor will come what? F into 1 plus 1, and 1 plus 1 2, 2f. Okay, so I intensity is equals to mod of f square, so it will come what? 2f square, so 4f square. But for forbidden to be happen, the structure factor should be 0. So when you will take s plus k plus l equals to odd, then this will come your minus 1. Okay, how? If you will calculate from here, it will come what? H plus k plus l is equal to, suppose it is a odd, so it will this formula, this expression will come minus 1. So 1 minus 1 equals to 0. So here it will give a forbidden reflection where the structure factor is your 0. Okay, so how it will get? When in the condition of your s plus k plus l is your odd, then it will give, or it will show the forbidden reflection. Why? The structure factor is coming out to be 0, and when it is even, it will come out to be 4f square. So this is the reason. So the h plus k plus l is odd, then it will show the forbidden reflection. Fine. Yeah. So this is also a kind of just showing the XRD. When you will have some XRD pattern, then how you will notice. So like for the BCC to be happened, the S plus K plus L here you can see should be, I think, even. So I will also show you the formula for the each in the last of this, all the I mean after completing this patterns questions. So here you can see for the BCC 100, no, 110, if there will be, then it will be BCC, and 111 not, because here 1 plus 1 plus 0 is equals to 2. And for the base, the h plus k is important. So the in here this should be your, I think, this, I mean, they have given in the formula, I think there is something like unmixed or mixed. So you have to check that. So yeah. So from here you can identify whether it is a base centered. So here this is a body. How? So here you can see the 110, 200, 211, and this is like your base. Okay. So this is unmixed. H and K are unmixed. So like 0, 2, 0. So here H is what? H plus K, 0 and 2. Okay. So this is your even 1, 1, 2 and 2, 0, 0. So this is unmixed. When H plus K is unmixed, then it is a base centered. And this is a body centered when H plus K plus L are even. So the answer was D. Okay. Again, okay, the same thing which I just said, because I was not aware that it was in my next question. So the base centered crystal structure shows reflection only when what? H plus K plus L even or odd, H K are unmixed, or H and K are mixed. I just told you. What will be the answer? Hello.
C.
Okay. So yeah, that is correct. I just told you like I mean, this is again the slide where they have explained. So this in the base center, this H plus K are even, and both, I mean, this should be unmixed, both either odd or either even. Okay. So like, okay, so this is for the base centered. So here you can see the H plus K. So here 0, 2, 0. So 0, H is what? 0. K is 2. Okay, here H is 1. K is 1. Here no, I mean, no much role of the L. Here it is also 200. So H is 2, and so it should be either even or odd. right? For base center. So that should be unmixed, either odd or either even, either odd or either even. It should not be like a mixed, like there will be zero also, one also, or two also, or one, like that. Either it should be a even or odd. So H and K are unmixed. So the answer is C. Okay, this is again question regarding which I have explained. So just again think about the crystal structure which are stored in the BCC and tell me the atoms that two, one is in the corner and another is in the center of the unit cell. So just you can guess it very simply. What will be? So answer this. Very simple question.
Yeah.
Okay. I want
It's
from
A.
other A.
It's A.
Okay. What about others? There are many people. Nobody is answering, and this is very simple. I have just explained in our previous slides also. So now I think you will get that. Okay. So this is very simple. For this corner atom 0, 0, 0, or for this body center. So from here, half in the x direction, half in the y direction, half in the z direction. You will reach to this location. So the UVW is what? 0, 0, 0 and 1 by 2, 1 by 2, 1 by 2. So this is answer A. I think nobody should have confusion for this if you know the location. Okay. Now the face centered structure shows reflection only when S plus K plus L are even, odd, or whether it is unmixed or mixed. So what will be the answer for FCC? Hmm? What will be for the FCC? What?
D.
D. H, K, L are mixed.
Next.
Okay. So, um, yeah. So this is for the FCC where we have calculated the number of atoms. So here, 8 atoms at the corner and 6 atoms at the face of the this 6 faces, and so it can combine with the 8 unit cell, and this can be with the 2 unit cell. So 6 multiplied by 1 by 2 and 8 multiplied by 1 by 8. So here it will come 4. So the FCC has a 4 atom. Okay, so this is the location of the atom or UVW for that. So if you will calculate the structure factor, and you will get, so when it is unmixed, okay, whether it is even or odd, so your structure factor will come what? F 4F. Okay, then if you will get it mode of this F square, then it will be 16F square. Okay, and when it is HKL is mixed, then what will happen? 2 even or 1 odd, then it will come what? I think it will come 0. So in order to, I think, get a reflection only when this should be unmixed. Okay, so the answer is your C. So here it is asking about the structure factor should not be 0. It is not asking about the forbidden reflection. So when you will calculate the this, so when this is unmixed, whether it is even or odd, then only your structure factor should not be equals to 0. So when it is even or odd, it means when it is unmixed, then your structure factor it will come 16F square, which is not 0. But when it is mixed, it will come what? It will come 0. So it should not be mixed. It should be unmixed, right? So here you can see that for the FCC, unmixed means what? Here it is mixed. There is a even or odd also. Here also even. So for the FCC, it should be like here you can see a 111. Here it is unmixed. All are odd. Here 200. It means all are even. 220. All are even. 311. All are odd. 331 all are odd. So for the FCC, you can easily identify it should not be mixed. It should be unmixed, either odd or even, in order to get the in order to get the reflection. So this is for your BCC, this XRD pattern, and this XRD pattern for what? For your FCC. So this is a very simple rule. So for this, the answer is your C, are unmixed. Yeah, so this I was saying at the last I wanted to discuss. So this is your brevis latis. So for the simple, for the base centered, for the body, and the face centered. So the reflection possibly present for the simple, then it should be all base centered. H and K should be unmixed, like I have said you. Okay, whether it should be a 1 1 or the like 0 2, whether it should be only even or the odd. For the body centered, H plus K plus L should be even, and for the face centered, H, K, and L should be unmixed. This is for the reflection to be present and reflection necessary absent. So here there will be any no any such things, and H and K should be mixed, and here H plus K plus L should be odd. It means in this case your structure factor will come around, the structure factor will come 0. Okay, in order to absent the reflection. Okay, or you can say the forbidden reflection. So the H, K, and L are mixed. So this relation apply to a cell centered on the C face if reflection are present only when H and L are unmixed, or when K and L are unmixed. Okay, so this is saying something. So yeah, one more thing, structure factor is independent of the shape and the size of the unit cell. So it's not something like if your shape is different or your size of the unit cell is different, then your structure factor will, because in the formula if you have known there will be HKL, so the location of that atom will be your similar. So it does not depend on the shape and the size of the unit cell, right? So this is the formula, just keep in mind whenever you solve the problem, and when you have any XRD pattern and you wanted to observe that what crystal structure it is. So from here you can easily identify that. whether it is a SCC, BCC, FCC, or the base centered, right? So yeah. Okay, so NaCl is, I think, very very famous crystal structure in this field. So it is asking about the reflection again. If you know how the atoms are located in the NaCl, then you can answer this. HKl are unmixed, mixed, and only HK are mixed and unmixed. So what will be the answer for this? Just think about the NaCl crystal structure.
B.
B. Okay. Others?
It's B, unmixed.
Okay, fine. Yeah. So let's see. So again, the structure factor should not come to the zero. Then we will see. Then yeah. Uh, the for the source. I mean here at the I think I forgot to include the, yeah, it is there. So this is your NaCl crystal structure. So where you will have this sodium ions at your this will make FCC if you will see it properly, and it will, the chlorine will be at the octahedral of this unit cell. Again, if you will see another crystal structure, then you can also say if your chlorine will make FCC crystal structure, then the Na will come at the octahedral of your unit cell, right? So this is how the atoms are arranged in the NaCl crystal structure. So here we will see when you will, okay, so when you will put the value of your this structure factor, it will come what? H plus k, k plus l, l plus h. So what it will come when you will calculate, this will come h plus k, sorry, hkl are if mixed, then this structure factor will come to 0. Okay, like 110100, and if it is unmixed, then it will come what? 4 into fna plus fcl, or if it is odd only s plus k plus l, then fna minus fcl. So your structure factor will not get 0. So what was the question? It was asking about the reflection. Yeah, so it should be unmixed. When it is unmixed hkl, then you will get a reflection. So this is about the unmixed. Okay, when you will calculate the structure factor, when it is a mixed, you will get 0 value. Okay, so it is, again, you can solve. Yeah, try to solve. You just I have shown you in the previous slide the formula. You just note down the formula for your this structure factor, and try to calculate by somewhere in your notebook, and by yourself, and try to just apply when the h and k are unmixed or mixed, or whether it is odd or odd even or only even. Then it will be a good exercise for you to understand this concept. Or for the better also, if you will stuck somewhere, you can also see the lectures where you can see how it is been solved. Yeah. So answer is B, it should be unmixed. So the NaCl crystal structure possess more than 4 atoms per unit cell, but the lattice is face centered. Less than 4 atoms, more than 4 atoms, but it is body centered, or less than 4 atoms, body centered. So it is very simple. I just showed you the uh, I mean the crystal structure of NaCl. What? See, just try to simple now. It is very simple. So when you will try to calculate here, this is your FCC. So FCC, if you will solve, how many atoms will come? It will come 4. And again, when you will solve this question, it will come also 4. Okay. So here more than 4 atoms per unit cell, but the lattice is face centered. Okay. It is like you can see it is face centered here, not it is not body centered. Okay. So just try to calculate the number of atoms as I explained in the previous crystal structure. It is just like a FCC crystal structure. Okay. So it is A, face centered and the more than 4 atoms. And how, if you wanted to know, I can also say it now, but please do this exercise.
But these are the four ions, na?
Yeah, this is sodium ions and the chlorine
And
ions.
chloride ions. So
Yeah,
four NaCl molecules, na?
this is asking about the NaCl crystal structure. When it will be crystal structure, but this is ions. When Na plus and Cl minus ion will come together, it will form a NaCl crystal structure. So which is right? This is Na plus and sodium ion, and this is chlorine ion. But it is asking about the atoms. Okay. So when you will calculate this, this is your FCC. So FCC, and this will also make a FCC. Okay. So just see that these atoms will um, combined with how many unit cell. Okay, then it will be easy for you to calculate the number of atoms. So 4 for the Na, 4 for the sodium ion, 4 for the chlorine ion. So more than the 4 atoms per unit cell, and the lattice is face centered, not body centered. Okay, yeah, and which is right, it is not sodium and chlorine, it is sodium ion and the chlorine ion. Okay, so the multiplicity factor for this plane, 100 plane in cubic and tetragonal crystal structure are what? 64822846. This is very simple. Do you guys know the multiplicity factor? So multiplicity, suppose if you I will take a example of a cubic crystal structure, and if I will take a 100, okay, then what could be from that family? We can write 100, we can write 010, we can write 001, 1 bar 00, 01 bar 0, 001 bar. Okay, so this is how. So the relative proportion of the plane contributing to the same reflection enters the intensity equation as a multiplicity factor. Okay. So here you can see the parallel planes with different Miller indices. Example 1001, 1 bar 00 are counted separately as a different plane. Okay, so that's why here comes the concept of your multiplicity factor. So here when you will take the cubic, so in the cubic 100, so for 100 how many it will come? It will come 6. What will be that 6? 100010, just I have explained. Okay, so it will come 6. Or when you will take a tetragonal crystal structure, okay, so for the tetragonal, what it will come? Tetragonal 100. Okay, so it will have a 4 when you will calculate this. Okay, so just try seeing this, and for 001 planes it will be come around, it will come to 2. Okay, so the multiplicity factor depends on crystal structure, whether it is a tetragonal or it is asking about the cubic. For the cubic it is 6, for tetragonal it will be 4. Fine. So this is how it will get calculated. Again the same question for 001 plane for the tetragonal case. So I think, yeah, for 001 it will be 2. Okay, just see how, just see the permutation combination, what will be that 2, just or just try searching that how, what will be the multiplicity and what will be that 2 plane 001, and apart from 001 what will be the others. Okay, so just try this for each and every crystal structure. Remember this, what is, I mean, there is a relation between alpha, beta, gamma and ABC for each and every crystal structure. From there you can be easily able to get it. Now, as a result of increase in temperature, the intensities of diffraction line remain constant, decreases, increases, and the background scattering decreases. So there is when effect of the temperature also. When you will do this experiment, there is called a variable temperature XRD, where we gives the temperature also. So here what will be happen in the intensities of the, okay. So here when the intensity calculation considered as a crystal as a collection of atoms located at the fixed point, okay. So here you can see the difference of particle before the heat. It will arrange like this: particle after heat, okay. So here vibrate a little atoms in fixed position, but when you will give the thermal energy or when you will give the temperature, the increase the kinetic energy vibration, okay. So vibration will increase as well as the expanded space between the atoms vibrated around the fixed position, so it will get expand, okay. So atoms undergoes a thermal vibration when you will give a temperature, but their mean position even at absolute is zero temperature, and the amplitude of this vibration increases at the temperature increases. So there is a effect of temperature, how you are this is happening. So the intensity of the diffraction line when you will give the temperature, it will decrease when the intensity of the background is scattering between lights increase. So here the intensity of diffracted beam decreases as the temperature is raised, or when you will increase the temperature, the intensity of your diffracted beam will get decrease, okay, because the arrangement of these atoms will get affected. The space between these atoms will expand, okay. So increase thermal vibration of the atoms as a result of increase in the temperature. So if there will be the more vibration uh, when you will give the temperature, so the unit cell expands and causing change in plane spacing. So there will be the change in the there all the setup, like you will change the d and 2 theta position of the diffraction line. So that's why the diffracted line intensity will decrease when you will increase the temperature, okay. So the answer was your B, means the intensity of diffraction line decreases when you will increase the temperature. So yeah, I think it's time is now over, and it's 8, and we have came across some questions which will be, I hope that it will helpful to solve your assignments. And if you have some doubts, you can ask, or if no, or you can ask it later also in the next class. So yeah, okay. Is it okay, guys? So see you later.
Okay, thank you.
Yeah.